kind of a lot to cover today. It's possible I will go a little bit long today. And it's also possible that I might take bits and pieces from a previous lecture and post that as sort of part 2 of the lecture. I'll have to decide, see how it goes today before I decide which way I want to handle it. Okay. I want to cover 3 main things today. I want to talk about your lab 3, where you calculated the student's tuition. There's a video posted about it, but I thought going over it in lecture would be a good thing to do as well. Maybe a different way to look at it. Then I want to talk about the difference between primitives and objects. Primitives and objects in Java. Lastly, I want to talk about an array list. Okay, and I have an example for that. So we'll talk about those 3 things. We'll see how far we get. And the rest, either I'll go long today, go a little bit longer, extend the class, or I'll make or use a previous lecture. One of the 2 will depend. First of all, as far as your homework assignment goes, computing the student's tuition. It's probably a harder problem than it looked like at first. If you just glance at the chart, it looks like it's pretty easy. If you're in county, you get charged $154.03 per credit hour. If you're out of county, you get charged $179.21. If you're out of state, you get charged $330.78. And if you went and did the math, that would be correct up to this point. Up to 12 credit hours, their tuition is the number of credit hours times whatever their rate was for 1 credit hour. However, between 13 and 18 credit hours, they have, students get charged the amount of 13. So if you take 13 credit hours, you get charged for 13 credit hours, or 13 times the rate. If you take 14, 15, 16, or 17, or 18, you also get charged the amount for 13. So it's not all just credit hours times the rate. There's a little section in the middle where the student gets charged a different amount than what they're taking. They're billed a different amount. They're billed for 13 credit hours if they take 13 through 18. And then here, they start picking it up again. In other words, if you take 19 credit hours, you get charged how much you get charged for 13 credit hours plus 1 additional credit hour. So effectively, you get charged for 14 credit hours. If you take 20 credit hours, you get charged for 15. You take 21, you get charged for 16, 22, 17. In other words, you get charged for the number of credit hours minus 5. So there's sort of 3 zones in here. All right, there's a zone for 1 through 12, there's a zone for 13 through 18, and there's a zone of 19 through 22. Now, some of you had hard-coded. If you take 1 credit hour, you get charged this. If you take 2, you get charged that. That will work, but that's a very inefficient way to do it, and it would be very difficult to make a change if they changed the tuition rate. You should actually do a calculation as opposed to just assigning it. So, one thing we can tell by this is that tuition is going to be the rate times the billed hours, which is different than the hours that they're taking. All right. How do we calculate the rate? We look at the type of residency code they have. If they're in county, then the rate equals something. So on down the line. What you also need then, so a lot of you got that part of it right. You looked at the rate, you looked at their residency code, and you assign their rate to be this. But then you also have to look at hours and write a statement that says something like credit hours less than 13. And I'm not writing full Java statements here. I'm just sort of sketching out the code. Then the build hours equals the credit hours. If the credit hours are between 13 through 18, then build hours equals 13. That's that middle section where they get charged for 13. Then finally, if the credit hours are greater than 18, build equals credit hours minus 5. Now, how do you do a range? You do a comparison. You would have to say something like if credit hours are greater than 13, and then have 2 ampersands, and credit hours are less than 19. So that's how you do the range. Both those conditions have to be true when you join it with an ampersand. So that in a nutshell is how you're going to do the calculation of the tuition. Please look at this. Also watch the video. Also look at the chart and make sure this makes sense for you. For lab 3, I think if you did something to calculate tuition, but it wasn't perfect, I think I gave you like 4 out of 5 points or 5 out of 6 or something like that, depending on how far off you were. But take a look at this and see if you can figure out how you need to do this and how you need to correct it. And if you have any questions at all, by all means, let me know. Any questions now?
Range one?
Yeah.
The 2 conditions must be met.
Right.
After the one where it says less than 19, is that where you would plug in, the credit hours minus 5?
No, the credit hours would equal 13 if they're between these. Okay. The credit hours would equal minus 5 in the case of credit hours being greater than 18. Right? Okay. Next thing we're going to do is talk about the difference between objects and primitives. Right? You hear the word primitive, think simple, basic. There's a number of primitives in Java. And let's look at those right here. There's 8 primitives: an int, a byte, a short, a long, a float, a double, a boolean, and a char. These are different ways to do numbers. Generally speaking, I would use ints for numbers if they were integers. I'd use doubles if there was a decimal point. There's also char, which means a single character. and Boolean, which is simply either true or false. Those are the primitives. Now, when you have primitives, try to do this in Word. As someone noted last week, when you have primitives, the name of the type is a lowercase letter. So if I want to make int x, or alternatively, I could say int x equals 0. What this is doing is this is declaring that this variable x is of type int, which is a primitive. Notice that the word int starts with lowercase. That's your tip-off of whether it's an object reference type or a primitive. Lowercase things start with primitive. Same thing with if we wanted a decimal point. Double. Double y. Now, if we notice something else, something else is defined with an uppercase, then it's an object reference. The first one that we've seen is string, where you might contain a name. All right, so that's all well and good. What does that mean? You know, is it just a matter of uppercase or lowercase? No, it goes beyond that. It deals with how data is stored in memory. All right. And that affects how it's stored in memory, affects doing things like comparisons, assignments, and pretty much everything. I'm trying to think what's the best tool for me to use. I'm gonna go into Excel. If I have a statement, let me make this bigger. I have a statement, int x equals 0. What that says is put somewhere in memory, and there's two sections of memory, the stack and the heap. Stack is where the variables get defined. The heap, we'll see what that's being used for in a minute here. The stack says find a location in memory, and just to be arbitrary, I'll give each location in memory a number. X means I'm giving a name to this memory location. And because it's a primitive, the value is going to go here. And that's true for any Boolean. If I say Boolean B equals false. In some memory location, these numbers are, again, just arbitrary. Don't think they mean anything specific. I'll have a variable B, and in it will be contained the value false. Right? So that's true for primitives. Object references, though, are different because the object itself lives in the heap. What lives in the stack is a pointer to the object. So if I say pizza P equals new pizza, and we've done that in our previous examples, What that's going to do is it's going to create a memory location called P. It's going to give that memory location a name. It's going to create somewhere in the heap, I'll say location 200. It's going to create a pizza object. And what's a pizza object have? As we've learned before, it's going to have methods and attributes. All those methods and attributes are going to live on the heap in location 200. What location 102 is going to hold is going to hold a pointer to that location. Let's look at this statement closely. Pizza P means we have a variable that's going to hold pizza data. I can only put a pizza in this memory location called P. If I tried to put a number in it, if I were to say P equals X, I'm going to get an error because you're trying to put a number in a pizza location. New pizza says create on the heap an object of this type. And if there's a constructor, you can set variables via the constructor, which I trust you all looked at last time. All right. So that creates a new object in a location. And when I say pizza P equals that object, what it's going to take is it's going to take the address in the heap where that pizza object lives. So if I were to say pizza P1 equals new pizza, it's going to do the same thing. It's going to create in location somewhere on the heap a pizza object that has all the methods and attributes. And let's say I set the size, we'll just talk about the size and we'll forget about the other parts of the pizza. If I say P set size and P1 set size to L also. And let's say I do that for all the attributes in the pizza. The size, the kind of crust, whether that's pepperoni or not, but we'll only look at size. If I do this, and if I ask then if P equals P1, this is going to be false. Now you'd say, well, it's the exact same pizza. It's the same size, it has the same crust, and it has, or both of them either have or don't have pepperoni. Because when you create this pizza, I forgot to finish the job here, P1, 201. When you compare two object reference types, it compares the pointers. See, not if their values of their attributes are equal, but if they are actually pointing to the same variable, pointing to the same object in the heap. In this case, P is pointing to this object, P1 is pointing to this object. All right, why are there two objects? Because I had two new statements. The pointer for this one gets put in P, the pointer in this one gets put in P1. So if I do this, this is going to be false because it's not the same pizza. If I do something like this, it's going to create a new variable in memory in some place. called y. And it's going to set the value equal to the value of the primitive. If I were to do this, if I did pizza 2 equals P1, what do you think that's going to do? That's going to create a new pizza in the stack, and it's going to assign it the pointer that is contained in P1. So now both P1 and P2 only point to one object, pizza object. So if I said P2 set size small, guess what? It's going to change that size for that pizza. And if I said system out println something like this, it's going to print the value of small. So if I change the one pizza, I change that pizza object, and both these two variables point to that object. Primitives are simple. The variable contains the name, or contains the value that is defined in the primitive. So an int primitive contains an integer value, a Boolean contains a Boolean value, and so on down the line. With objects, however, they're called object references because they don't contain the object itself, they contain the pointer to the object. Which means that you could have two variables that point to the same object. In our example, both P1 and P2 both point to this one object. So if I do something for P2, I'm changing that same object that P1 is pointing to. And it's going to do comparisons on whether they're equal based on not the values of the attributes, but on the values of the pointers. Do you have any questions about that? We'll probably play around with that in our example, and we'll see examples of this throughout, but I did want to introduce that to you at this point. It's important to understand that in many cases, because everything you do with objects, you're doing with pointers that point to an object.
Any pointers to one object?
Absolutely. Here we have two, but you could have more. P1 and P2 point to that object because I said P2 equals. How many objects are created? Just glancing at this code, there's two of them because I have two new statements. New is what makes the object. Now here's another trick about object references. If I were to say P equals P2, it's going to copy the pointer into P. Now nothing points to P to this pizza in location 200. In that case, that memory gets reallocated. It's known as garbage collected. Because an object that nothing points to doesn't do you any good. You can't access it. You have no variable to get to that object. And therefore, Java notices that and says, well, I can get rid of this object. All right. Another famous thing that you often see is a null object reference. And that is if you did something like this. If I said pizza P3 and then said P3 dot set size to something. Well, P3 doesn't point to any object. I've created that variable and I know it's going to hold a pizza, but I have not created via a new or from another assignment an object to point to. And very often if you do something like this, maybe not like this exactly, but if you do something like this, you'll get the dreaded null object pointer exception. If you ever see that error, it means that you're trying to call a function on an object that doesn't exist. All right, let's look at the pizza example that I have increased to include orders. So I'm going to look at the order class. And I'm going to open the pizza class. And I'm going to open the unit test. Didn't want to do that. Pizza class. We haven't really changed anything on that, except a couple of things. As soon as I say we haven't changed anything with that, I noticed something we changed. There's two things we changed. One is we changed and we added a calculate price method. Basically, we're going to charge $8 for a small pizza, $10 for a medium, $12 for a large. We're going to add an extra $1 if it's thick crust, and we're going to add an extra $2 if they have pepperoni on it. So a small thin crust without pepperoni would be $8. A medium thick crust with pepperoni would be 10 plus 1 plus 2 would be $13. The other things we did is we added constructors. And in our case, we have actually 3 constructors, because you can have more than one constructor. And Java is going to know which constructor to use based on the arguments that you give the constructor. A constructor is simply a way to create an object and assign values at the same time. In my example I was showing you a minute ago, I just said pizza P equals new pizza. I used a no argument constructor. And if you don't define any constructors, you can do that. If, however, you define constructors, then Java does not provide you with the no argument constructor, and you have to supply and write all the constructors that you want. So in this case, I'm going to create a pizza using a statement something similar to this. To use this constructor, I would say something like pizza P equals pizza, and I'll give it the size, I'll give it the crust, and I'll give it whether it has pepperoni or not. I give values for those 3 arguments. Now, why do we have more than one constructor? This allows us to default certain attributes. for example, if we don't supply whether it has pepperoni or not, if we just give the size and the type of crust, then it's going to assume you don't want pepperoni. If you only give the size and don't give the crust or whether it has pepperoni, it's going to assume no pepperoni and thin crust. If I were to call pizza P equals new pizza small, then it's going to create it. It's going to give the size to small, set the size to small. It's going to set the crust to thin and set has pepperoni to false. You can have as many constructors as you want, but you can't have two that have the exact number and type of arguments. So I have, for example, here an argument that only accepts the size, one string. I could not write another constructor that accepted a string that could be used to set the value of the crust and assume that I want a medium pizza that was thin crust, or a medium pizza that I would pass the argument whether it's a crust or not. Because it wouldn't be able to tell which one I wanted to use if I gave it a string. It wouldn't know to use this one or the new one that I hypothetically developed. So this should largely be reviewed with the exception of the constructor, which should have been talked about in the lecture I posted for last week, and also the calculate price. Notice I'm using crust.equals thick instead of saying not crust equals thick. Because again, when we do equals, we're comparing pointers. And this is a string and this is a string, so we'll be comparing these two pointers. And this might not give us the results we're expecting. So we use the equals function to do that. All right. Now, here's where the fun starts. All right. We have an order class. If you think about it, what is a pizza order comprised of? Call your local pizza shop and you put an order in. Typically, you give your name and your phone number. Those are attributes of the order. All right. There's a list of pizzas that you're going to order. Now that list might be one pizza, or if you're like having a big event, maybe you're ordering 12 pizzas. There's not a fixed number of pizzas that you're ordering. Okay? So, plain old arrays in Java, once you declare the size, they can't be expanded. So that wouldn't work very good here. What we're going to do instead is use an array list. Because an array list, we can add as many pizzas as we want to it. So we define that we have an array list of what? Of pizzas that we're calling pizzas. And that is equal to a brand new array list that we're creating. The reason we put this pizza in here is so we can't put any other object in that array list that's not a pizza. If you imagine if we expanded this, all right, and if our restaurant also sold sandwiches or salads or whatever, we would not be able to put an object of salad into the pizza array because that pizza array is only expecting pizzas. Now, later on in the semester, we'll figure out a way that we could put pizzas in salads, but for now, we're not going to think about that. I have a constructor for order that's going to accept the name and the phone number that I set. I have my set methods and get methods. I have a method to add pizza to an array list. The way that you can put something in an array list is to add it. and that'll put it in the next spot in the array list. So the first time I do this, it's going to put it in spot 0. The second piece I add is going to be put in spot 1, and so on and so on and so on. I have two other methods. I have calculate bake time and calculate price. And these correspond to the get and set method, or the calculate bake time and price on the pizza class. Now, what is the bake time for an order? Well, the bake time for an order is going to be whichever pizza takes longest to bake. Let's make some assumptions. All right, so don't tell me I'm not able to run a good pizza shop, because this assumes you can bake all the pizzas at the same time. All right, so this assumes a really big oven. All right. And therefore, if I have a pizza that's going to take 10 minutes and a pizza that takes 16 minutes, well, the bake time for that order is going to be 16 minutes, right? Because I put them both in at the same time. 10 minutes happens, I take the first pizza out. Another 6 minutes happens, I take the second pizza out. So the total time would be 16 minutes. So I'm going to loop through that array list and determine who has the highest bake time, and that's the bake time for the whole order. When I calculate the price, I'm going to loop through all the items on the list, and I'm going to sum up the prices, and I'm going to return that price. It's exactly like an accumulator. Both of these do the same thing. I have a for statement that says for I equals 0. So I'm starting at the beginning of the list. Go as long as I is less than the size of that array list. The size is how many elements are in it. So if I have 8 pizzas, the size is going to be 8. I'm going to do this for pizza 0 through 7. All right. I'm going to get that numbered pizza from the list. That's what this statement does. It's a function on the array list to get that pizza in there. And then I'm going to ask for that pizza's bake time. Here I'm going to ask for that pizza's price. Add it to the accumulator. So this is a very common syntax to loop through and look at each pizza in turn, get the next pizza, and either compare the baking time or add the total price together. Now there's a slightly different syntax you can use to loop through. That's using a for each syntax. That one. This is the other syntax. For string, well, this is a string. In our case, it would be pizza. For pizza object that's in my list, this loop will execute each time and grab each object that's in my array list. Two different syntaxes. I learned this way first, so that's why most of my examples are written this way. And you're welcome to use either of them. And I think if you look at some of the other resources I gave you, it shows you how to do the for each in more details. Now, one thing about an array list is array list can only save objects. It can't save primitives. Now, there are these wrapper classes called integer and double and so on that you can use to sort of turn an int into an object. We'll talk about that right now. All right, now let's look at our unit test. Now, one thing that I try to emphasize is that you need to test your code thoroughly. Here I've created a pizza using the 3-argument constructor to give the size and the type of crust. And it's going to default the value for pepperoni. Here I've called the constructor that only sets the size and defaults the crust and the pepperoni also. And here I've created an order, added those 2 pieces to the order, and come up with the total cost of the order and the bake time for the order. Let's go and run this. All right, there's my classes. I can do Java C, star.java, and I can run them. Java unit test. All right, first pizza is small, thick crust, does not have pepperoni. The bake time is 16 minutes and the price is $9. Is that correct? Well, what should it be? Well, I know small is $8. There's no pepperoni, so we're not adding the extra $1 there. And thick crust was an extra $1, so that's $9. And I know thick crust is 16 minutes for the bake time. This one's large, thin, and no pepperoni. So the price of that is $12 for large, and the bake time is 10 minutes. So the cost of the order is $21 because I've added these 2 pizzas in here. And the bake time is 16. So these are correct because the greater the 2 bake times gets assigned to the bake time of the order. The cost is the sum of the 2 costs. Now, this isn't really a thorough enough test, right? Because there's things I didn't test. I never tested the constructor that accepts 3 arguments. I never tested anything that has pepperoni on it. All right. So coming up with the test cases to test your code is really important. So for example, to really test your tuition calculation, at the very least, you would need 9 tests, but you probably would be better off with 12 tests. A student is in county that has between 1 and 12 credit hours, a student that's in county that has between 13 and 18, a student in county that has greater than 18. And then the same thing for out of county and out of state. If you really want to be good, you're going to test the border, right? You're going to test 12 and 13 to make sure 12 shows up one way, 13 shows up another way. That's why I said that the idea would probably contain 12 test cases. So testing is very difficult, right?
essentially want like all three options, at least one for each zone.
Yeah,
One for the bottom of the zone and the top.
exactly, exactly. Now, this is called white box testing. White box testing is you know what the code looks like. So for example, I know that the cost of pizza depends on kind of crust, whether it has pepperoni, and the size. So to test this, I should have at least one of each size, at least one with pepperoni, at least one with a thick crust, and one with a thin crust. And for bake time, I should test one that's a thin crust and one with a thick crust. So quite a few tests. And again, I didn't test it thoroughly. Now, getting back to what we talked about earlier in the class. If I do this, let's say P5 equals P1. Actually, I'm going to say pizza, P5 equals P1. Then I'm going to say P5 set crust to thin. All right. So I define pizza 1 as having a small size and thick crust. Pepperoni is going to default to false. Say pizza 5 is equal to P1. I then say P5 set crust is equal to thin. So what's it going to say here when I output the crust for P1? Going to be thick because I declared it here, or is it going to be thin because I said it here? P1.
Okay.
Okay. Actually, it's going to say thin. Why is it going to say thin? It's going to be thin because at this point, P5 and P1 point to the same object. So they point, if you remember, there's pointers to the heap that contains the object. And if I set the object that P5 points to, or the object that P1 points to, they're both pointing to the same object. And therefore, if I went to print that out, it's going to say that it is thin. If that's not obvious, we'll bring this up a bunch of times. All right. I wanted to introduce that concept, but we are going to spend more time talking about this. So if I compile it and run it, it tells me the first piece of crust is thin.
That second pointer is more or less overwriting.
No, it's not overriding. It's not overriding it. It's literally pointing to the same object. So let me draw this on the. So I say, I'm going to abbreviate because it's hard writing on this. Pizza P1 equals new pizza. And I set the crust to thick. What does that do? That creates in the stack a variable called P1 that points to an object in the heap. Let's say at location 200. There's a pizza object. That pizza object has a crust, a size, whether it has pepperoni. So we're not interested in the crust or we're interested in the crust, not the size. So the crust is going to get set to thick. So P1 points to the object that's in location 200. All right. I then say pizza P5 equals P1. So P5 now points to pizza that's in location 200. So if I said get crust now, it would say thick. All right, because it's going to go out to 200 and look, say, hey, what's the crust for that pizza that's in 200? So if now I say P5 set crust to something, goes out to location wherever that points to 200. All right, that's this. It's going to change this to thin. Then I say to output the value of P1 get size, or get crust. It's going to go out to 200 and grab the crust, which is thin. All right. So in this case, at this point up to here, there's only one pizza. And it goes by two names. It goes by P1 and P5. So if I refer to P1, I'm referring to the same pizza that if I refer to P5. So if I use P1 to change an attribute, I'm also changing the attribute for the pizza that's found in P5. There's just one object out there on the heap that gets used. Any questions about the array list? Notice the instruction here is to add that pizza. I have an add pizza method in my order that takes whatever pizza I pass it and add it to the array list. When I then call calculate price and calculate bake time, it loops through all the pizzas that are in that array list and determines the bake time and adds up the price. Now, how's this gonna work with your assignment? Your assignment is to create an array list of courses, right? Your student is going to be like the order class. Your student is going to contain a list of courses. This is like the next lab, which is lab 4, I think. Yeah. Yes. So for lab 4, you're going to add an array list of course. You're going to create a course object that has a name, a code, and a number of credit hours. You're going to add an array list of courses to your student because the student has a list of courses that they are taking. You're then going to add to the student to calculate the total credit hours. And that'll loop through the array list, get each course, and accumulate the total number of credit hours that the student is taking. There's some students that every semester that go and add a list of students to the course class. That's not what we need in this assignment. That's also valid. And if we were creating a class roster, maybe you would have something like that. But you don't need to do that for this one because all we want to do is get totals for students, get the total number of credit hours a student takes, and then use that in the calculation to calculate tuition rather than the attributes in the student. Questions about this?
Yeah.
Okay. Well, again, thank you very much. As I mentioned before, I'm going to go up to lab and I'll be there either if you want to come in person or if you want to drop into my WebEx room. All right, we'll see you next week.